Idaho's economy is driven by agriculture, and the lifeblood of Idaho agriculture is its continuous, reliable source of water. Water that also brings to the state additional recreational opportunities, hydropower, and fish and wildlife habitat. For Idaho farmers, that water is delivered from two primary sources: surface water, including the Snake River and other smaller drainages, and from wells, where water is pumped from groundwater aquifers. Every growing season, thousands of acre-feet of water from these two primary sources are delivered to Idaho farms by a series of river systems, pump systems, canals, laterals, and farm ditches. But how do we keep track of who needs what water, and how much each water user should receive? And how does it get there? That's what this program is about, accounting for water that goes to every user by employing various measurement devices and careful, regular monitoring of those measuring tools, and then keeping accurate records of those measurements, because each irrigation district, each water user, must be assured that they each get their proportionate share of available water. Over the course of this program, we will explain why consistent and accurate measurement and accurate record keeping is vital for every irrigation district, canal company, and farmer. We will review the fundamentals of velocity and head and how they relate to flow. We'll look at the various measurement devices, and we'll show you various situations which can cause improper measurement and what you can do to correct those problems and to ultimately reach the desired goal: a consistent and accurate measurement. Back in the early 1900s, some of the Bureau of Reclamation's water projects were already under construction. Those dams, reservoirs, and diversion structures were built primarily for storage of irrigation water. These reservoirs also provide Idaho citizens with additional hydropower and recreational areas. Most of Idaho's large water storage and diversion projects were completed by the 1950s, which helped much of the dry Idaho desert become some of the most fertile farm ground in the world. Back in the first half of the century, water for these projects seemed abundant. Water users established water rights, which secured the water they needed to raise their crops. Other uses have also found their place within these massive water projects. Today, water is in big demand, and that demand defines water as a valuable and limited resource. Demand for water is only part of the reason that accurate and consistent water measurement is maintained through the growing season. Other reasons include distribution capabilities, application rate of chemicals, water loss control, and legal requirements including maintaining accurate records. Water measurement is a key link in the chain of understanding a water system's distribution capabilities. Earl Corliss with the Bureau of Reclamation serves as the manager of river operations on the Snake River, and he describes this vital relationship.
Okay, many farmers see this as the beginning of the irrigation process. For the ditch rider and irrigation managers and water distribution people, it's actually the end of the process. We have to know how much water is needed here and at what time, so that water can be released from the rivers through the main canals and right on down to the individual farmer's ditch. Really, it all starts right here. When all of the farmers up and down the river system on the various irrigation districts total up their daily needs, they then call those in to us as river operators, so that we can turn out the proper amount of water to them through their canals and head ditches. And that's one of the reasons that water measurement is so important, so that we will have the proper amount of water here available for them at the time they need it. And that just translates right on upstream to the various other dams and reservoirs that are in the system.
Before we move into the measurement devices, let's review the units we use to measure water. They are units of discharge and units of volume. Discharge, or the rate of flow, is defined as the volume of water that passes a particular reference section in a unit of time. The unit of discharge generally known is the cubic foot per second, also known as the second foot. In some parts of Idaho, there is still some use of miner's inches. 1 cubic foot per second is equivalent to 50 miner's inches in Idaho. The unit of volume used is the acre-foot. An acre-foot is defined as the quantity of water required to cover an acre of land to a depth of 1 foot. That's equivalent to 43,560 cubic feet. To better understand the relationship between cubic feet per second and acre-feet, it is useful to know that 1 cubic foot per second for 24 hours is about 2 acre-feet. Discharge or flow and volume are the basic units of measurement used throughout the discussion of measurement devices. In this next section, we will examine how flow is measured. Because most devices measure flow indirectly, we will look at those water measurement devices that measure for velocity and those that measure for head. These are the devices that, used with the appropriate tables, will give you an accurate measurement for flow and volume. The most common methods and devices to measure velocity are current meters and inline propeller meters. There are several devices commonly used that measure head, and they include rectangular weirs, V-notch or multiple notch weirs, Cipolleti weirs, Parshall flume, meter gates, fixed submerged orifices, constant head orifices, Venturi meters, and weir gauges or sticks. Before we go further in this section, it will be useful to have a clear meaning of what is described by head.
As we discuss water measurement, and especially water measurement over a weir, you'll hear the term head used a great deal. And what head is actually the depth of water operating on that structure. In terms of a weir, it's the actual depth of water from the weir crest up to the surface of the water that's going over the weir. And the recommended procedure for obtaining the head that's operating on the weir is to come a given distance upstream and install either a staff gauge or, as we have in this case, a stilling well. This stilling well is connected to the pool and it has a staff gauge inside, and in order to get the head measurement, you just read the water surface here, and as you can see, it's very calm and easy to read. That will give you the head, and you convert that through a table to the amount of water that's flowing over the weir.
Almost all head measurement devices have found their way into Idaho's irrigation systems, but some are definitely more prominent than others. One of those devices is the Cipolleti weir, used in conjunction with a weir stick.
Okay, here we have a standard Cipolleti 4-foot wide weir, and you notice the sharp edge construction. That's necessary so that the nap of the water will spring free and provide the close measurement. Now, we talked about placing a measuring staff gauge upstream, but in absence of that, a very accurate and acceptable way of measuring is with the weir stick. And to do that, you go to the center of the weir, turn the weir stick perpendicular to the flow and also in a vertical direction, and read the buildup. And in this case, we have a reading here of 0.57 feet. You would then go to a table for that weir, and 0.57 feet of head on that weir is equal to 5.80 cubic feet per second.
Weirs come in all sizes, from the small 4-foot Cipolleti weirs you've already seen to the larger broad-crested weirs that are entirely submerged. Cipolleti weirs also come in an adjustable form, which is used for adjusting the water surface elevation and measuring the water. Another weir that has seen some use on Idaho irrigation projects is the V-notched weir.
Here we have a V-notch weir. Probably the best application of a V-notch weir is in small ditches, as you see here, to measure small flows. The V-notch weir is, this is a 90-degree angle. Again, it should be installed level. The sides should be sharp and straight, and the best way to get a measurement from this weir is to have a staff gauge mounted upstream with the 0 point on the staff gauge level with the bottom of the V notch. Then you just merely take a reading from your staff gauge, apply it to a table, and that will tell you the amount of water that's flowing through this structure.
Broad-crested weirs are designed to accurately measure flows over a wide range of flows.
We've been talking about Cipolletti weirs and other types of free-flowing weirs. Another kind of weir that is gaining more popularity here in Idaho is the broad-crested weir that we have here behind me. Broad-crested weir has several advantages. It is very accurate, it's easily maintained, and can provide real-time data. Some of the disadvantages are that on the larger system, they are relatively expensive to construct, and you must have each individual site calibrated and run through a computer program to design the size and shape of the structure. However, those computer programs are available here at the Kimberly Research Station at the University of Idaho. As you see here, we have this one automated. There's a stilling whale behind me. The readings are taken every 15 minutes, relayed via that antenna to a satellite. And this is one of many stations in Idaho that are connected to our hydromet system and provide this information on a real-time basis throughout the state.
Another common water measurement device is the submerged rectangular orifice, also known as the fixed opening orifice.
Here we have a submerged orifice. This particular orifice measures 18 inches by 6 inches. It's very important that those dimensions be exact and that the opening be sharp, straight, and level. The best way to think about these is that this is a 1/2 foot and this is 1 1/2 foot. The cross-sectional area of this particular orifice is 0.75 square feet.
Fixed orifice devices are just that. They are fixed in one position. But there are orifices that are adjustable, so that head can remain constant. They're called constant head orifice, or CHOs. It gives the water manager the ability to both measure and regulate that flow.
What we have here is a constant head orifice, or CHO. It has some advantages and disadvantages, as all measurement structures do. Advantages, of course, it's a fairly compact unit. It can be constructed rather easily. In contrast to other type orifices, it has 2 gates instead of 1. The disadvantages of it, the measuring orifice is down below the water surface, and if any moss or debris gets in there, it will destroy the accuracy of the unit. Another advantage, major advantage of a CHO is that it can operate with very little head loss between the canal and the delivery point. In order to obtain a measurement from this device, first of all, you would decide how much water you wanted to discharge, and you would look that up on the table that applies to this particular structure. And that then would give you a opening for the gate. And so you would adjust the opening with this wheel until you got it at the desired opening. Then you would come to the downstream gate and adjust this gate until you got the constant head between the canal surface and the water surface in the gate itself. And that's obtained by reading the difference between this gauge and one just like it that's on the outside. And having that information, then you would know the discharge through this structure.
So far, we have covered weirs and orifices. Both measure head. But there are also flumes used in many of Idaho's irrigation districts, and flumes also measure head. The partial flume is one of those devices, and it has an advantage over weirs and orifices.
During this discussion, we've been talking about weirs that obtain discharge by measuring head. Another device that measures head in order to obtain discharge are the flumes, one of the most popular of which is the partial flume, and this is an example of one of those. The advantages of partial flumes are that they are universally used all over the Pacific Northwest. They are easily fabricated from a variety of materials, from steel to concrete. They're relatively inexpensive and fairly easy to install. The disadvantages of a flume of this nature is that they must remain level from front to back and from side to side. Now, to obtain a water measurement through this flume, you would either have one that would have a permanently installed staff gauge at this point, or you could just take a weir stick, as I'm doing here, and take a measurement. In this case, it measures 0.26 feet, and you would take that to a table for a 6-inch partial flume, and that would give you the amount of water that is flowing through this structure.
The trapezoidal flume is also used on Idaho irrigation districts and has many of the same advantages of the partial flume.
Here we have another example of a flume. This is a trapezoidal flume. It differs from a partial flume in that it has sloping sides and does not have the descending throat that a partial flume has. Therefore, it can be installed in a flat concrete ditch or any type of a flat ditch where you don't have a lot of head loss. The measurement is obtained by this restriction in the cross-section of the ditch, and the head in this flume is measured, in this case, on the slope. To obtain a measurement through this flume, you just take a reading here and go to a table calibrated for this flume, and it translates into cubic feet per second that is passing through this device. Here again, as in the partial flume, this must be installed level, front to back, and from side to side in order to ensure accuracy.
Weirs, orifices, and flumes are the key tools water managers use to measure head. They all have advantages and disadvantages, and yet they've all found their way into Idaho's irrigation systems. In the next section, we'll look at devices that measure water velocity. All of the devices we've talked about so far allow you to measure the operating head over the structure, which is then converted into a flow measurement. But there are many measurement devices used throughout Idaho that also measure velocity. One of those is the inline flow meter.
In closed pipe systems, the most widely used method of water measurement is the inline flow meter, such as we have here. They have several advantages. One of the advantages is that it has several methods of obtaining a water measurement. It has an instantaneous hand. You can walk up to it, open it up, read the hand there, and this particular meter is calibrated in gallons per minute, presently pumping just over 1,000 gallons per minute. Has a totalizer here that you can take a reading on a 24-hour basis and therefore determine how much has gone past. Or you can take a stopwatch and time a complete revolution of the small hand here and calculate that, and also obtain a instantaneous flow of what's going through the pipe. Now, in order for these to be accurate, you should have approximately 10 diameters of unobstructed pipe upstream from the meter, and in order to maintain accuracy, these meters should be removed from the pipe and gone through completely cleaned and greased and that type of thing in order to maintain the accuracy of this flow meter.
Meters, flumes, weirs, orifices, and other measuring devices are designed to do one thing: give an accurate and consistent water measurement under the proper conditions. To assure yourself of an accurate and consistent measurement, follow these basic steps. Install properly constructed and calibrated standard measurement devices. Be sure that your device is free of obstructions. Make sure that the device is properly calibrated. Record your measurements and maintain a permanent record of these measurements. And finally, if you have a question about the accuracy, installation, design, or maintenance of the measuring device, ask the manager of your irrigation charts, tables, and other information concerning water measurement you might need.
From Jackson Lake Reservoir up in Wyoming to where we are here at Milner Dam, the Snake River flows for about 350 miles. It serves irrigation water to 1.25 million acres. It serves over 100 irrigation companies and thousands of farmers. Once it arrives at this point, the reservoir here, in order to ensure correct deliveries, must be maintained to within 0.2 of a foot of elevation. None of that would be possible if it were not for good, precise, and accurate water measurement.
In addition to your managers, you can contact the Bureau of Reclamation or the Idaho Department of Water Resources or the Idaho Water Users Association for more information about water measurement. They have all the materials, books, pamphlets, and personnel to help you become better water managers.